Hi, I'm Volker Bentvelsen. I work at Ch2, together with my co-authors Jelle Assink and Leslo Evers. And we are curious if we can peruse the IMS to gain information on winds at some 10 kilometers altitude. So we want to track these jet stream winds specifically through mesoscale gravity waves arriving on arrays of microbarometers. Let's start out with why do we even want to study the jet stream? And that is because it's tightly coupled to the weather that we experience at the surface. So on a large scale, severe weather events can be linked to specific jet stream configurations. To make that statement a little bit less abstract, I've brought this illustration of such a configuration of the jet, where we can see two local maxima called jet streaks and their positioning relative to the low pressure area at the surface. So in this case, due to this positioning, the snowstorm that was there typically had 50 of snow falling in a matter of only 2 days. Now this is just one example, but in general the point is the jet is linked to the surface weather, and that's why we want more information on its parameters. It's not so easy though. There is a suite of techniques to observe at 10 kilometers altitude, but the problem is they all have their challenges. So we want to provide the solution in the form of an independent observational technique. And that's what we're researching. So I'm very grateful that I got an internal research grant from the Ch2 to look into this. And today I will be presenting on the part of it where we try to, through gravity waves measured at microbarometer arrays. Let's go back a bit into history, because what we're looking into is not completely new. Already in 1969 in New York, Heron and Tolstoy had an array of pressure sensors, and they split their pressure time series into 4-hour windows. And on these 4-hour windows, they did beamforming. And with this technique, they were able to reconstruct the directions of arrival and the apparent velocity of the overpassing gravity waves there. And they could already find the relation to the winds overhead, so to the jet stream. Now, more recently, of course, we've had the development of the IMS with currently 54 arrays of the infrasound section being certified, providing data. Well, Martí et al. In 2021 already showed that a subset of those are definitely capable of observing gravity waves. And we do a sort of proof of concept, more specifically on one of these arrays, the I-26 array, on the band where we can find mesoscale gravity waves. So we took 1 to 2 millihertz, which you can see in the figure as well. So we did something similar to what Heron and Tolstoy already did. We did beamforming on 4-hour windows, and we retrieved the parameters of these gravity waves, and we relate them to the overpassing winds in the column above the array. Now we did that for a climatology of 5 years. And in this, when we bin all the detections, we can see seasonal dynamics. So here we have the directions of arrival, also known as the back azimuth. And we bin them per month and per direction bin. We can see that most of the detections are coming from the westerly sectors, but in the winter months, there's a bit of a shift to more northerly detections. Now, we did something similar to the estimated signal to noise ratio of the detections, but in this case, the vertical axis is not directions, it's just the hour of day. So we can see both the cycles within a day and the cycles within the seasons. And the coloring is the estimated signal to noise ratio. So what we can see here is that our detections have a higher signal to noise ratio in the winter period in general, and in summertime during nighttime when the atmosphere is stable near the array. And the lower signal to noise ratios are during summer days and in spring. Now we want to compare these detections that we did to this IS-26 array, and we also have a nearby airport at Munich where radiosonde balloons are launched. So the vertical profile above the array and the vertical profile from the radiosonde soundings provide a comparison for our detections. As you can see in the bottom left here is an example of that. We can also do that in time series, so then we can already start to see some things. Here we only compare to the level at 250 hectopascals, which is 10 kilometers roughly. And there we can see that in the periods where the wind is stronger, we can take some threshold like jet stream. So wind is jet when it's stronger than 25.7 meters per second. And in these periods, we have a correspondence between the directions of the detections and the directions of the model and the radiosonde balloons, what they estimate the wind is. Now, on the contrary, near section C, where the wind speed is low, the detections become less corresponding to what's in the model and radiosonde soundings. Now, if we look at another time series, I can pick out something else with this example, that is that the source mechanism of these gravity waves we think might have to do with the dynamic shear instability. And this happens when the Richardson number is in a critical range of 0 to 0.25. And when we look at the vertical profile, where we not only have the direction, the velocity and stability, but also the Richardson number we calculated, then we can see that near this height of 250 hectopascals, we see that the critical Richardson number is here, and also the direction is corresponding. And that is nice. But we also did some more robust statistics on the entire climatology, and that we show here, where we show the circular to circular correlations in the entire profile. And when we look at that, we can see that all throughout the troposphere, we find significant correlations. Um, and in the boundary layer, these become weak um, and even surpass zero. And higher up towards the stratosphere, these correlations also disappear. So what is my take-home message here? There is information on the winds at the height where we typically find the jet stream in these mesoscale gravity waves that we can observe at least the IS-26 array. And they're in southeast Germany. The gravity waves predominantly come from the west, but they also have a seasonal cycle where they shift to more northerly directions in wintertime. And all throughout the upper troposphere, we find significant correlations between the directions of what we find from the Era 5 model and radiosonde balloons and what we can observe at the IS-26 array in the mesoscale gravity wave band. So that's it from me. Thank you for your attention. If you have any questions, I should be here on the WebEx to, well, talk to you about them. If it's not possible, also feel free to send me an email at the email address you see. Thank you.